Welcome to RSCH503, Research Methods in Biostatistics, a 3-credit graduate course offered by Drexel University College of Nursing and Health Professions. When using correlation coefficients to determine if a relationship exists between two variables, the critical question is this: is the R obtained statistically significantly greater than 0? In other words, if the correlation in the population is 0, could a correlation as high as that obtained in the sample have resulted from sampling error alone? An R significant at the 1% level, that is 0.01, means that chances are no greater than 1 out of 100 that the population correlation is 0. Hence, we conclude that the two variables are truly correlated. What does the word significance mean? Or the phrase statistically significant? Significance levels refer to the degree of risk of error we are willing to take in drawing conclusions from our data. Behavioral research typically accepts significant levels at either 0.01 or 0.05. It is very important to understand that significance levels are determined by the decisions to be made on the basis of the data analysis findings. Correlation coefficients and statistical significance are employed in determining reliability and validity of an instrument or test. One means of determining the reliability of a test or instrument is to conduct what is called test-retest reliability. In this method, a test or instrument is given to a subject on 2 different occasions, and Pearson's R is computed using scores from the 2 sessions. The error variance in test-retest reliability includes the random fluctuations in test or instrument performance from session 1 to session 2. This is referred to as time sampling. The interval between test or instrument sessions should not exceed 2 months, since maturation of subjects may otherwise influence results. If the interval is too short, there is the risk that subjects will recall their answers from the previous session. This is especially true when reasoning or ingenuity tests or instruments are being utilized. Another form of determining the reliability of a test or instrument is called alternate form reliability. This involves giving a subject equivalent forms of the same test or instrument and then computing Pearson's R using scores on the alternate forms. The R obtained is a measure of both temporal stability and consistency of response to different item samples. The error variance in alternate form reliability is both time sampling and content sampling. The length of the interval between test or instrument sessions needs to be identified in the test or instrument instructions. A third means of determining the reliability of an instrument or test is called parallel forms reliability. The 2 parallel forms of the test or instrument must meet the same test specifications, number of items, etc., as well as the same testing conditions. Pearson's R is then computed using scores on the parallel forms. The limitations of alternate forms reliability are: 1. Practice effects are reduced but not eliminated. 2. Will the nature of the test change with repetition? And 3. There are practical difficulties in construction of parallel forms. Another method of determining the reliability of a test or instrument is called split half reliability. In this method, a single test or instrument is administered in one session, and 2 scores are obtained by splitting the test or instrument into 2 forms, with Pearson's R obtained from scores on the 2 halves. This R is a correlation coefficient of internal consistency. The most common means of splitting a test or instrument is the odd-even method. A statistical technique called the Spearman-Brown formula can be applied with this method. Also, the longer the original test or instrument, the more reliable it will be, but again, only up to a point. With the Cooter-Richardson reliability method, a single test or instrument is administered on a single occasion, and the R computed is based on the consistency of responses to all items on the test or instrument. The Cooter-Richardson reliability method is an inter-item consistency method. The error variance with the Cooter-Richardson method includes content sampling and heterogeneity of the behavior domain sampled. The more homogeneous the items, the higher the inter-item consistency. Thus, if the items on a test or instrument are heterogeneous, the Cooter-Richardson reliability method cannot be used. Inter-item consistency of a test or instrument can be determined by two statistical methods. First, the Cooter-Richardson formula can be used, but only for a test or instrument with two choices per item. For example, true-false items, right or wrong items, etc. And second, Cronbach's alpha formula, or coefficient alpha, can be computed on a test or instrument with more than two choices. For example, a test or instrument with Likert scale responses: strongly agree, agree, disagree, strongly disagree. A very common method of determining reliability of scores of behavioral observations, writing samples, or other tests or instruments is called the scorer reliability method, or inter-rater reliability. In this method, two raters for a test or instrument, or for a behavioral observation, provide scores independently, and a correlation coefficient is then computed to determine score consistency. This method is very commonly used in behavioral observations. The limitations of this method are consistency or lack of consistency among raters, and the need to train raters with a standard method. To summarize, there are four sources of possible error variance in determining reliability of a test or instrument. Each type of test or instrument reliability may have risk of one or more of these sources of error variance. First, temporal fluctuations. Second, content sampling. Third, inter-item inconsistency. And fourth, scorer variance. Again, recall that a statement of the normative sample must accompany research instruments. This statement needs to include the sample size, or capital letter N, characteristics of the sample, and the reliability and validity coefficients obtained. Instrument norms represent the test performance of the persons constituting the standardization sample. Instruments may be used with samples similar to the characteristics of the normative sample. They may not be used on samples with different characteristics. When reviewing norms of a test or instrument, recall the following. 1. Increasing the sample size, or capital N, increases the stability of norms. 2. Increasing the representativeness of the sample increases the external validity of the test. That is, it increases the generalizability of the norms. And 3. A test or instrument must clearly define the population from which the sample norms apply, thus informing researchers about the internal validity and external validity of the instrument. This presentation was prepared for graduate nursing students at Drexel University College of Nursing and Health Professions. The primary book used in this research course is The Practice of Nursing Research, Appraisal, Synthesis, and Generation of Evidence, 2017 edition by Jennifer R. Gray, Susan K. Grove, and Suzanne Sutherland. This book was published by Elsevier Saunders, St. Louis, Missouri.